So today we'll discuss the 2023 Advanced Level Physics MCQ paper. The first question is, electron volt is a unit of. So this question was asked several times in the past papers. Electron volt is actually a unit of energy. So the symbol is E times EV, and the energy here is approximately equal to 1.602 times 10 to the power minus 19 joules. By definition, it is the amount of energy gained by the charge of a single electron moved across an electric potential difference of 1 volt. Actually, this potential difference here, potential difference is can be written as the difference in potential energy. So the difference in electric or electrostatic potential energies divided by charge, or it is the difference in electrostatic potential energies per unit charge. So if you multiply the potential difference by charge, if you just do the cross multiplication here, you get the difference in potential energies. So actually the product of potential difference and charge gives you energy. So here the correct answer is answer number 1. Question number 2. The distance between the centers of two uniform spherical masses, capital M and simple m, is simple r. What is the gravitational potential energy of the two masses? So here again, in the previous question we discussed about electrostatic potential and electrostatic potential energies. Here they are asking about gravitational potential energy. So here you know the equation for gravitational potential. So gravitational potential, the equation is negative Gm over r. This is not squared, it's just an r. So again, with regard to gravitational fields, the potential, gravitational potential can be stated as the potential energy which gets stored in a unit mass. So gravitational potential can be defined as gravitational potential energy divided by mass. So to get the gravitational potential energy, again you have to do the cross multiplication, and you can just multiply this gravitational potential by mass. So here the correct answer is answer number 2, minus negative Gmm over r. So the derivation of this equation is another topic. We'll discuss it under gravitational fields lesson. Question number 3. When a bull pulls a cart, what is the force that causes the bull to move forward? So they are asking the force that causes the bull to move forward. So if the bull has to move forward, the force should be acted upon the bull. So actually this force is exerted by the ground. So the bull is pushing the ground backwards. So if I draw some picture here, so actually what happens is the bull, he pushes the ground backwards. So according to Newton's third law of motion, an equal and opposite reaction will occur, and the ground will push the bull forwards by an equal and opposite force. So here the answer is the force exerted on the bull by the ground. So this is a question related to Newton's third law of motion. Question number 4. Two displacements of magnitude 9 meters and 6 meters can be added to give a resultant displacement of. So here displacement is a vector, which means that it has a magnitude as well as a direction. So this question is asked regarding addition of vectors. Here if you consider the addition of vectors, so there are two vectors here. One is 9 meters, the other one is less than that, which is 6 meters. So if both the vectors are in the same direction, the resultant vector will be in that direction and the magnitude will be 9 plus 6 or 15. If the two vectors are in the opposite direction, if you add the two together, what you need to do is to subtract this 6 from this 9, because they are in the opposite direction, and the resultant of the direction of the resultant will be towards the vector which has the higher magnitude, is towards this direction, and the magnitude will be 9 minus 6, which is 3 meters. So if you just consider that these two vectors are at an angle theta like this, and the vector addition, if you add these two together, the value should lie between this 3 meters and 15 meters. So the maximum sum will be 15 and the minimum sum will be 3 meters. So out of the answers, the only answer which satisfies this is answer number 3, which is 4 meters. Question number 5. Longitudinal waves do not exhibit. So this is regarding the properties of waves. So there are some properties of waves that you need to know, such as reflection, refraction, wave interference, diffraction and polarization. So out of these 5 properties, only this polarization is only shown by transverse waves but not by longitudinal waves. All the other characters are characteristic for both transverse and longitudinal waves, but polarization is only seen in transverse waves. Question number 6. It's regarding black body radiation. If the absolute temperature of a black body is increased by 2 times, the energy radiated by the black body per unit time per unit area will increase by. So this question is from the Stefan Boltzmann law, or simply the Stefan's law, which states that the power radiated by the unit area of a black body is proportional to the 4th power of absolute temperature, T to the power 4. So if this absolute temperature is increased by 2 times, then the power radiated per unit area will be increased by 2 to the power 4 times, which is equal to 2 times 2 times 2 times 2, or 2 times 2 4, 4 times 2 8, 8 times 2 16. So correct answer is answer number 4, 16 times. Question number 7. When transistors are used in digital circuits, they operate in the which region? So they are asking the region. The important point here is the term digital circuits. So in digital circuits, it's working according to a binary fashion. That means only ones and zeros are there. So here the transistors in digital circuits, they are typically operating in the saturation and cutoff regions. So there is another region, the active region. Mostly in analog circuits, transistors are used in this active region, in which it can be used as an amplifier, but here in digital circuits transistors are used mainly as a switch. Here the saturation region represents the binary 1 or the on state, whereas the cutoff region represents the binary 0 or the off state. Right. So that is also an interesting question. So question number 8, what is the quark composition of a neutron? So this question is coming from the particle physics. So neutron is a neutral particle, so the charge is 0. So if you consider the standard model of particle physics, so this is the standard model of particle physics. So here there are quarks and leptons here. So out of the quarks we are mainly dealing with this up quark and down quark. So up quark has a charge of plus 2 over 3, while the down quark has a charge of minus 1 over 3. So the composition of the neutron is composed of 1 up quark and 2 down quark. So if you add the charges together, plus 2 over 3 minus 1 over 3 minus 1 over 3, the total charge becomes 0. If you consider the proton is made up of 2 up quarks and 1 down quarks. So considering the charge, it's plus 2 over 3 plus 2 over 3 minus 1 over 3. So if you add these three together, you will get plus 1 as the answer. So out of the answer, the fourth and fifth answer, they are giving this U bar means this anti-up. It is the antiparticle of this up quark, and D bar means anti-down. It is the antiparticle of this down quark. So we will discuss this under particle physics in a matter and radiation lesson. Question number 9. If the pressure of a given mass of an ideal gas is kept constant, the variation of its density ρ with the absolute temperature T is best represented by. So you can just consider the ideal gas equation here, because the question is asking about the ideal gas, about an ideal gas. So it's PV equals nRT. So this can be written as PV equals, N can be written as M over capital M mass divided by the molar mass RT. So here you can rearrange this equation. P equals M divided by V RT over N. So here M over V is the density. So P is equal to density ρ RT over N. So if you just subject this ρ, you can see that the density is inversely proportional to the absolute temperature. So that means the graph will take the form of answer number 5, because when the temperature is increased, the density should get reduced. Right. Question number 10. 3 thermodynamic processes are given below. A. An isothermal process. B. A constant volume process. C. A constant pressure process. All the heat energy supplied to an ideal gas is converted to work done by the gas. So the answers have been given. You can see the difference of the pressure volume curves on with regard to the processes, the thermodynamic processes that we are concerned with. So according to the first law of thermodynamics, in a system, if the net exchange of heat is delta Q, the change of internal energy is delta U, and the amount of work done is delta W, then delta Q is equal to delta U plus delta W. Here delta U is the change of internal energy, which is dependent on the temperature. So in an isothermal process, isothermal means delta U is 0, that means there is no change in temperature, that means the internal energy is constant. Delta U is 0. So if delta U is 0, delta Q becomes equal to delta W. So here the question is asking the instance where all the heat energy, so delta Q is the heat energy supplied to an ideal gas, is converted to work done. So delta W is work done. So it is during an isothermal process in which all the heat energy supplied to an ideal gas is converted to work done by the gas. So the answer is only A. So if we consider the other processes, constant volume process means there is no change in volume. So the work done, delta W, is equal to pressure times change in volume. So if the change in volume is 0, then the work done also becomes 0. So in a constant pressure process, the pressure is kept constant. So the heat supplied will be used, some amount will be used for this delta W, and the other will be used to change the internal energy. So here the answer is an isothermal process.